Okay, welcome to today's video. What we're going to be doing today is we're going to be modeling and also creating the engineering drawing for this part right here. This is a quick change tool holder. All of the dimensions are shown on the drawing itself. We're going to take this, we're going to model it up in 3D in Solid Edge. After we've modeled it up, and of course added the materials, we're going to then go into the drafting environment and create the engineering drawing similar to what you're seeing right now. So with that said, let's take it to the next step and let's open up Solid Edge. Okay, so what I've done here in Solid Edge is I've actually sketched out the base just beforehand. It's an ANSI inch drawing, so a lot of you already know how to start a file. So if not, remember you always have to start when you go new. You're going to end up starting. In this case, it's an ANSI inch part, and then select the plane that you're going to start working with. I've selected, in my case, the front plane, and that's how I sketched it out. Okay, so if I click on the little house symbol next to the view cube, it's going to show what it looks like. Now, just to show you what all the dimensions look like on here, and again, this is simply one process of sketching. There's tons of ways of doing it, but I'll show you how this one I ended up doing and assembling. So off of here are all my dimensions. So it's really a cross section of half of the part. The reason I'm doing that is that I'm not going to use extrusions. You can do this in multiple ways. You can create, for example, circles and extrude the main body to a little more than 2.5 inches long, so on and so forth, and then continue extruding different circles off of that. What I pretty much decided that this is a contiguous sketch. It's a closed loop. So rather than using circles, I'm going to use the cross-sectional profile and use that with the Revolve tool in order to get my initial shape. So with that said, I'm going to close my sketch, finish and cancel it. Okay. I'll just click on this corner of my view cube, just zoom in a little bit. And as I said, I'm not going to use the extrude tool. I'm actually going to use the Revolve tool in this. The bottom straight line is going to be the axes. So I'm going to do two picks. I'm going to select the profile, and then I'm also going to select, after I accept it, I'm going to select the bottom edge as my axis of revolution. So let's select the Revolve. Step number one, we're going to select the contiguous sketch. As you can see, all points meet up. So I'm going to click. That is acceptable. I can hit enter, or I can click the check mark. And then the second thing that it also needs now is the axis of revolution. So the axis of revolution will be the bottom edge right there. As I move my mouse, it starts creating the revolve. I want it to go 360 degrees, so I'm just going to click on the donut right here and finish and cancel the sketch. So in a nicely set up system as this, it's a very simple way of creating the majority or the main body very quickly. Okay, so we have the main body. Now there's a few additional features that we have to add. One of the features that we have to add is, if we take a look, there is, in fact, we'll just go back to the drawing itself. There is a small little notch here. It's almost a little keyway. Its dimensions are, it's 0.17 wide, and it has a diameter value that indicates how deep it goes into. So if it's a diameter value, it lends itself very easily to using a radial distance to figure out how deep this is going to cut. And it's actually a really easy way of creating this. So let's go back and see how that works. So I'm just going to go back to Solid Edge. I'm going to start by clicking a sketch. So I'm going to start with my sketch. In this particular instance, rather than trying to pick it off of the screen, I'm just going to use the base reference planes. I'm going to click the front view, which is probably the most logical view to do. Let's center this. I'm just going to do a nice little fit, zoom into where I want, and then I'm going to use the rectangle tool, 2 points, and I'm just going to rough out the general shape. Okay, so that's what the cutting tool is going to be looking like. I can add some dimensions to start putting the intelligence. So the first thing I'm going to do is I'm going to add a dimension to here, and it's giving me the wrong dimension. Hold on 1 second. Just make that nominal. And so let's type in 0.17. Enter. Okay, and it's giving me something that I don't need here, so I don't want my preview, so I'll just clear the preview. Click OK, and then that dimension is actually the nominal. And there we go. Okay, so now I have that. Okay, let's add a radial dimension, and the radial dimension is going to be from the center to the bottom. Drag it over here, left click. Okay, and this is, again, it's giving me a radial, preface. So let's highlight that. And from the detail view, it tells me it's a diameter of 0.937. So I'm just going to type in 0.937, and I'm going to divide that by 2, and it'll give me that. And as always, let's get rid of the preface, apply, click OK, and again, that, apply, click OK. Okay, so now it tells me exactly how deep it's supposed to go, but it's not in line. So how am I going to place it in line? I'm going to use a relationship. So I'm going to use this particular relationship, which is the collinear, which is right there. So I'm going to click on collinear. I'm going to select this edge, and I'm going to select that edge, and it'll snap into place, just like that. Hit escape. Now, I don't really care how tall this is, because it's a cutting tool, so I'll just leave it like that. If you want to put a dimension, it's totally up to you. Let's close our sketch. Go isometric. Oh, we do need one more thing, sorry. So let's go back here. Yeah, we do need one more thing. We actually, let's finish it, cancel. We need an axis of revolution. So I'm going to just add that to my sketch. Like that. And again, that line does not have to be any particular distance. Let's close our sketch. Okay. Now, what we're going to do then is we're going to use not the revolution, we're going to use the Revolve Cuts. I'm going to click on Revolve Cuts, select that shape, accept it, select the line, and then the donut, and then click Finish, Cancel, and now we have our little cut. Okay. All right, let's continue forward. As always, what I like to do is turn the sketches off, that way it doesn't distract. Okay, there are a couple of main features that we have to add now, and that is there's a bore hole that goes all the way through the piece on both ends. On this end, it's just a straight bore hole. On the other end, it's a it's a counterbore hole, which also has a threading feature on it. So we're going to start by creating this bore hole here, and this bore hole here gives us a limit, and then that limit is 1.5015 to 1.500. We always take the maximum material condition, meaning we always take the smallest because it's a lot easier to remove material than it is to add material. So we're going to use the 1.5 measurement that's on the drawing. And so I'll just show you what that is, and it's right here. So we're going to take the lower level, we're going to take the 1.5, because if the limit's indicating that we can remove a total of 1.0015, because we have material, it will allow us to remove material. If I take this limit and it's actually this size, then I can't go back because I've already removed the material. So let's go back into here. Now there is quite a few ways of doing this. I am actually going to take and use one of the tools that I always like using, and that's the hole command, because in reality this is a hole. In reality it's a counterbore, and we have the values for that counterbore. We have the 1.5, which is the counterbore. We know what the depth is, and the depth is 2.5 inches, and then the actual through hole is 0.578 in diameter. So we have all the information that we need to use the counterbore tool. So I'm going to just click on hole command. As always, when you click on hole command, your first step is to go to the options. From the options, we're going to change it to counterbore, which is right here. And I'm just going to type in the values because that's really all I need to do. So the through hole, the bore, is 0.578. Okay, enter. The depth is 2.5. And then the counterbore itself, as we indicated, is 1.5 in diameter. Okay, we also want this to go all the way through, so we're going to use the through all. Click OK, and then we're going to select the surface of the back end of the tool holder. Okay, position our sketch for the hole right at the center. Okay, hit escape, and we'll just click the house symbol, and then finish our sketch, and finish again, cancel, and what we should see is that it goes all the way through. Excellent. So we now have the first of the features. The second feature we're going to add is on this end, and this end, we go back to our drawing. So in this end here, we actually have a threaded feature. We also have a counterbore. In this case, the counterbore is 0.75 in diameter. That's the counterbore. Its depth is 0.156, which is right here. The thread itself is 0.8, but the actual hole goes in a total of 1 inch. So we have all the information that we need to actually set this up. Plus, because it's a threaded, we're going to use the threading option within the hole command. So let's go back to our program. We're going to go into hole, options. We're going to use them to our counterbore, and we're going to lay out some stuff. The first thing we need to do, though, is we have to activate the threads, which is right there. We also have to indicate is it an external or an internal thread. In reality, it's a tapped drill diameter, so we're going to pick that one. Okay, so the thread itself, we're going to pick off of the list, and it's a 5/8. Okay, because the thread itself is indicating it's 0.625, so it's a 5/8 by 18, which is a UNF. So it's a fine thread, which is right there. So there's the thread. That's fine. How deep is the thread going to go? Well, we're going to change the 2 to 0.8. Okay. Next, we are going to leave the hole itself as is because the hole itself is dictated by the drill tap. The diameter. Well, the diameter is 0.675. So 0.675, which is the diameter of the counterbore. And the only other thing we also need here is how deep the counterbore goes down, and it's 0.156. We have all those numbers off of the drawing. Okay? So, we don't want this to go to next. We actually want it to go into a finite. So it's the first choice right here. The reason is that we only want the depth to go to 1 inch. Okay, so we have all of the numbers that we have required. So click OK. I'm going to select my surface. As always, I'm just going to place it right at the center. Hit escape. Finish my sketch. Click finish, cancel, and now if we rotate, and we have that counterbore hole including the thread. Okay, so we're looking pretty good. All right, so our next step is there are a couple of key tabs on this flange right here, and it's shown on our section view. So if we take a look at our section view, so there it is. There's a couple of key tabs, and those key tabs, once again, we have an overall opening. It's indicating where it's going to be. Well, here it's also giving you a dimension to indicate where it is from the center. What we're going to do is on the modeling end of it, we're just going to use one of the relationship tools to center the cutter tool. But we also need to know what our distance or how the depth is. As always, we look for maximum material condition. This is an internal feature. So if it's an internal feature, what we're looking for the smallest version. So here we have 1.755. It has a plus of 0, and then it has a minus of 0.005. So we're looking for the smaller version. So if we minus 1.755 and we subtract 0.005, we actually end up with 1.75. That is the distance that we actually want, because then we can actually remove additional material. Okay, so we're taking the 1.75 as our distance between these, but because of that, and we also know where the center is going to be, we're going to divide that by 2. Okay, so let's lay this out. Let's go back into Solid Edge. Okay, I'm just going to revolve this around, create a new sketch, and it's right on that surface right there. Okay, I am going to, as always, use a straight 2-point rectangle. Don't really care what the size is, just like that. Okay, we're going to put in a dimension. Okay, that dimension is the entire width of this. So the entire width of this is 0.64. So we're going to type in 0.64, enter. Okay. Now what we want to do is we want to line up the center of this edge to the center of the hole. And to do that, we can use dimensions, or we can use the horizontal vertical tool. If I click on that, I select the center of the rectangle I just created, and the center of the part right there is going to snap, and it's going to line perfectly in place. Okay, so the next step is where exactly or how deep is it going to go? Well, we're going to use an in-between. So the distance in between is going to go from the center to the edge. Let's drag up. And we had indicated it was 1.75. That's maximum material condition. Okay, between the two sides, that's the distance. That's the best distance that we have. But then we're going to divide that by 2 because it's going from the center, not from edge to edge. Divide that by 2, hit enter, and that's exactly where it's supposed to be. Now, if I hit escape, I can drag this in a little bit. I can add a dimension if I want, but it's really not necessary in this case because it's already encroaching onto the surface that I wanted to cut. Okay, so let's finish our sketch. So we're going to finish our sketch. we are going to do an extrusion this time, or actually, cancel. We're actually going to do an extrusion cut. We're going to select, click OK, and then we're going to make sure that it's going to go through to next. Make sure that the arrow is pointing into the material. If you click here, you see the little exclamation mark coming in. That's saying you're trying to cut air, which means nothing. So make sure it's into the material, left click, finish, cancel. Now I could have done the same thing on this side, but remember this part is symmetrical. One of the things we've been talking about is when something is symmetrical, there's tons of tools that we can use, and the tool that I'm going to use is the mirror command. So I'm going to pre-select the cutout, which is right there. I'm going to click on mirror. I'm then going to go to my base planes. So my base plane that I want is my front plane. When I click on that, it creates the opposite side extremely simply. There we go. So now we've got the keyway cuts. Perfect. Turn the sketch off again. It's good practice because then at least it gives you a clean model to look at as opposed to all of these sketches and planes that are always resonant and don't necessarily need to be. Okay, so the last series of features, or the most important features now that we have to add, is we have to add a couple of holes to the top here. Now these holes are going to go all the way through into the pocket that the Counterbore made. However, they have to be placed tangentially. So as soon as that happens, we know that we cannot sketch on a curved surface, so we need a helper object. And that helper object will always be a plane. So the plane that I'm going to use here is, I'm just going to click on my planes, which are right there. And the plane that I'm going to use here is the tangential, which is at the very bottom. When I click on tangential, as always, I'm just going to rotate so I can see. I'm going to select the surface first, and then I'm just going to rotate to where I want. Now I want a percentage or an angle to indicate where it's going to be. Well, you have two red arrows, the red arrow that's pointing in the Y direction and the red arrow that's pointing in the Z direction. Well, I want the angle between those to be exactly 90, so I'm going to type in 90 degrees. I'm going to hit enter, pick anywhere in space, and there is my tangential work plane. So there's my work plane. Okay, what this does now is it allows us to sketch. So I'm going to click on sketch, just like so, and then I'm going to do the following. I am going to lay out where those holes are going to be. I am going to create two lines, or actually, I'm just going to create 2 points in space through that line in order for us to find where everything is. So first off, I'm going to simply draw a center line. So I'm going to click and then just draw a center line from one point to another point. Okay, hit escape. Okay, there's my center line. I'm going to finish my sketch. And because these are holes, as always, I'm not going to create circles. I am going to create, I'm going to actually create holes. Why? Because if we take a look, these are actually holes. They're 3/4 inch 16 pitch UNF internally threaded holes. If I created 2 circles, just the same rationale. If I created 2 circles, then I'd have to go back and create threads and stuff like that. The information will not carry through when I'm creating my drawing, so I have more work to do. So it might sound cliche, you always work smarter as opposed to harder. Okay? So we know what it is. It's 3/4 by 16 UNF. That's fine. Let's go ahead and do it. Okay, so to do that, we are going to click on circle, or actually we're going to click on hole, sorry. We're going to select our options as always. Now, this is a threaded hole. It is not a counterbore, so we're going to pick threaded, which is right here. Okay, so from the threaded hole, make sure your standard is ANSI, which is what it defaults. It's a standard thread, no problem. All we're going to do is we're just going to find the size we need. We're going to click on the pull down, scroll down, okay, and 7/8. There we are here. Okay, so we're going to pick the 3/4 by 16 UNF. Okay, so 3/4 by 16 UNF. Depth, well, we want it to go to next, so we're going to leave the default there. Threading, well, to the hole's extent, which is right there. Okay, we want it to be a tapped hole, which is right there. Make sure the tapped hole is indicated, so that's fine. Okay, so we're going to now simply click OK. We're going to select that work plane we just created. Okay, and I'm just going to take my cursor and click hole number 1 on that center line I just created, and then hole number 2 on the same center line. Okay, hit escape. We need to add some dimensions. We need to add the dimensions to the center line. So the first dimension we're going to add, we take a look on our drawing, is 1.125, and that will be the distance from that edge to the first hole. Then the spacing between the two centers is 0.938, which is right here. So let's take a look. Okay, we're going to use the in-between. We're going to use the in-between. We're going to select the edge, and we're going to select the center of our hole, like that. And we indicated it was 1.125. Okay, enter. Don't care if it overlaps. Okay, and then we're going to go and do the center to center, and we'd indicated that that is 0.938. Okay, enter. There they are. Okay, let's finish our sketch. Finish, cancel, and there are our holes, and you can see where they're going through. Okay, so now we have our main parts. Now we're going to pretty this up a bit because we're going to add a couple of chamfers. The biggest chamfer is going to be on this side, and that is going to be a 0.3 by 40 degree chamfer. And again, we can see it right about here. Okay, so let's go to our chamfer tool. Okay, it's 0.3. We're going to select the edge, accept, finish. Okay, now these little chamfers, we're going to simply make them just to break the edge. We're going to make them say 0.05. That should work. Enter. So we're going to select that and accept and see what we get. Looks good. Pick that, accept. Let's go here, pick, accept, and finish, cancel, and there we go. Okay, there's a slight little round over here. So we're going to also put in a couple little rounds. We'll make it 0.03, and we will make the rounds okay, so we've got the majority of what we need to put here. There is only one more thing, and it's the same thing that we always do at the end of a modeling project. We change the materials. So let's change the materials. We're making this out of steel, no problem. So we're going to go apply, and I'll turn the final sketch as well as the plane off, do a fit. Okay, so part one is done here, which is the creation of our model. So now we're going to take it to the next step, which is part two, which is the creation of the drawing itself. Okay, so here we have our sheet, and as always, this is an ANSI.dft file. It's got the border, it's got the title block. It's a little big, it's a D size, so we're going to simply change the size. We're going into sheet setup. We're going to pick the background tab and change it to a B size. It's about 11 by 17. That's more than enough. Click OK. Let's hit the fit. Okay. So our first step is to create our view, and we're actually only going to be needing to create one view in this case. It'll be the front view. So I'm going to click on my view wizard. Okay. From my view wizard, I am going to go to my tool holder. Okay, so here's my tool holder. Or actually, okay, sorry about that, picked the wrong one. Let's go tool holder, click OK. There it is. And we're going to leave it at 1:1. It's fine. So we'll leave it at 1:1. I'm going to select the starting point, say approximately here. Okay. I'm also going to create an isometric, but I'm going to start that, and then I'm just going to use, just for practice, I'm going to use my principal extraction view. So select, drag it, say, to about there. Okay, hit escape. Now this view, I don't need it that size, so I'm going to make it, say, half of its size. So click the down arrow, half of it, and I can move it over here. Approximately like that. It's a nice little isometric view to just give us an idea of what's there. Okay, let's create our views. We actually have 3 special views to create. We're going to create a section, we're going to create a detail, and we're going to also create a couple of broken outs. Okay, so if we take a look at the picture, this is what we're going to create. We're going to create the section view, we're going to create the broken out view here, broken out view here, and one detail view right there. Okay, so let's walk through that. Okay, section view is the easiest, so I'm just going to zoom in so I can see. The section view will go through this flange, so we're going to click on our cutting plane. We have to create a cutting plane first. I'm going to select my view, and then I'm going to pick the middle of the flange itself, go approximately here, drag straight down. Okay, hit escape. So now we have our line. We're going to click on close cutting plane, and we're going to want the A to point in that direction. Let's point in that direction. Okay, there is our cutting plane. We are then going to click and create our section. Here's our section. I'm going to select the cutting plane, drag out, say to about here, hit escape. Now let's take a look at the section. Remember, a section, you usually do not have hidden lines unless the hidden lines actually give you more information. The hidden lines actually confuses as opposed to give you more information. So I'm just going to click on that view, right mouse button, and as always, just go to the properties, which is the bottom. Okay. Make sure you go to the display tab, take the check mark off of hidden, accept, click OK, and it gives you a nice clean section view as you want it. So there's our first view. Our second view, we're going to use a detail. So I'm going to click on detail, zoom over here. And remember what I told you, the detail view if you use an anchor, you're not going to be able to move it, so you can't really position it. So I'm going to use my detail. I'll just zoom a little bit here and make sure nothing's beaming off of here. Left click once, drag. Okay, so that's pretty much what I want. Drag it over here, and I'll click, say, about there. Okay, so there's my detail. Always make sure that you hit escape and the letter for the detail is always outside of the object, never on the inside. So I can click and select and move that like that. And as I said before, because this isn't anchored, I can actually tweak it a little bit like that. Okay, so off of here, we can now start adding some dimensions. So the first dimension I'm going to add is the width and also the depth in itself. So I'm just going to go and click on Smart Dimension, pick, there's the width, okay, and then the depth, I'll select, and click. Actually, for the depth itself, I'll just leave it for now. I will use a call out later, but for now that works out well for the section, or excuse me, for the detail. Let's take a look at the section view. So the section view, I'm going to add the following. I'm going to add its opening. So the opening is going to be edge to edge. That's fine. Where is it located? Well, we can add a dimension from center to there. Okay, so that works out perfectly. And now the overall. So the overall, I'm going to do from here to here, drag up. Okay, now what I want to do is I want a plus or minus. Okay, so I want plus or minus on here, and the plus is going to be 0, 3 decimal places, and minus is going to be 2 decimal places and a 5. So I'm going to do that. I'm going to use the following. I'm going to select the dimension, and then I'm going to indicate the type of dimension that I want. So I'm going to click this button, and then I'm going to scroll down. So it's a unit tolerance that I want. So there's my unit tolerance. Okay, so now for the unit tolerance, I'm going to indicate what the plus is. So the plus is going to be 0.000, and then the minus is going to be 0.005. And there's my unit tolerance. Okay, so all we're doing is we're just changing the type. Hit escape. Okay, let's start adding the main dimensions here. So I'm not going to go through every single dimension, but I am going to go through a few of them. The first one I'm going to do here is I'm going to go through that. And incidentally, this is a diameter, so I'm going to select, and in the prefix, I'm going to make sure that that is a diameter symbol. Apply, and I get that. Okay, click OK. So there's my first diameter symbol. I'll just move this over a little bit just to make it a little bit better. So let's just move it over here. Okay, and I'll move this dimension outwards a little bit, something like that. So now we have to do the counterbore, but the counterbore itself we can't because it's never dimensioned to hidden lines. So we are going to do the following. We're just going to continue dimensioning what we can see. So we are going to dimension from here to here. So there's our first dimension. Okay. Then here. So in this case, it is wanting escape, because we're going to put an angle there. So we're going to go from point A to point B, which is right there. Okay. Our next step. No, I made a mistake, sorry. Delete. It's actually from here to here. That's better. Okay, so we'll just add that. And the next step that we need is here. So we'll add that. We're going to move some of these. Okay, and our last dimension will be here. Okay, so I'm going to hit escape, and I'm just going to drag these down a little bit like so, just to clear it from that. Okay. So we're pretty much set. We can also put a dimension at this end right here. Just like that. And as always, this is a plus or minus. But in this case, this is going to be a limits. So we're going to select, and we're going to change the type to, in this case, limits. So the upper is going to be 0.985, and then the lower is going to be 5 here. Oops. Okay. Okay. And sorry about that. Let's try this again. Got a little confused. So right here, there's our limits. So we're actually doing the subtraction. So in this case, 0.985 is the top end. The bottom end is going to be 0.002. And that gives us that. Okay. So now we have that. Okay. So the majority of the other dimensions, other than, for example, if I want to place an angular dimension, I'm going to place an angular dimension here. Between here and here. All right. Okay, this is 60 degrees. So we'll do, make sure we don't get it into the way of anything. We'll do, I usually like the acute, but in this case I'm going to use the obtuse. So it's 120 degrees, that's fine. Okay. And we can also put an angle here if we want. Okay, so from here to here. in direction. That's better. We'll put that there. That's a convenient location for it. Okay, so we have the majority of the dimensions we need, and this is where the specialized views comes into play. So we're going to add 2 specialized views. The first one is going to be a broken out view here, so we can dimension where the holes are. We can also see where the holes are. So to do that, I'm going to go, here's the broken out. I'm going to select my view, and then I am going to create my border. So the border itself doesn't really matter how you create it. So I'm just going to approximate how it's on there. So from here, like that, that, and like this, and I'll just go and have it straight through like that, and then finish it off. So that's good enough. A little more complicated than I would like, but no problem. Okay, so I'm going to finish my sketch. Now it's going to ask you how deep it is. Well, easiest way of doing it is to just take it to half of what the actual diameter is. So it's 2.5 in diameter, so 1.25 will be the depth. I'm going to click OK, and then I just want to select the view that it's going to be affected to, just like that, and then I have that. Now I got rid of a lot of dimensions because it was quite a few things. No big deal, because we can always put them back. So here and here, that's fine. But now we can also place our diameter. In this case, it's going to be a limits. So as always, I'm going to go from here to here, drag out, and again, these two, because they're both diameters, are going to require diameters. So I'm going to select, and then I'm going to go into my preface, click, apply, close, and then cancel, then click, prefix, diameter, apply, and OK. Okay, so now I have this, but this is a limits, so it's 1.500 on the bottom and 1.5015 on the top. So let's change that. So we're going to click, and we are going to select our limits, which is right there. We actually want, as it's shown, we want 4 decimal places, so we're going to increase the decimal place to 4. Okay, so here on the bottom it's the easiest one, it's 0, and on the top, actually, sorry, not that. We're going to use the limits. That's better. So 0 on the bottom. On the top, we have to add the 0.015. So we're going to go and type in 0.015. Okay, click. So there it is. And in reality, we only need 3 decimal places. Sorry, I'm getting away from myself here. Okay, it should be 0.0015. There. So now we have that dimension. Okay, we're going to add where the centers are. So from here to here, and then here. Okay. We're also going to add callouts. We're going to add one callout feature, click. I'm going to select, I'll pick it from that side and drag it up. And as always, this is 2 times because we have it 2 times there. So I'm going to select that and then put in the call out times 2. Click OK. So we have that. All right. We're also going to, because we can, also indicate what the bore is, which is right there. That's fine. A couple of dimensions have gotten out of place, so I'm just going to grab that. Just move them back down. Okay, it's looking good. And then the last thing we're going to do here, oh, we do need one more dimension. This. So this and this. Okay. And as always, this is a diameter. Okay. That is a diameter. We also need this and this. This is another diameter. It's fine where it's located. But as always, we also have to indicate that it is a diameter. Okay. Last but not least, we are going to, and in fact, this is not everything we need to add the chamfers. We can add those later, but I'm just going to add the main features. I do need to expose what this looks like. Okay, so it's going to be another broken view or broken out view. I'm going to click on broken out view, select, and for this one, all I'm going to do is just simply create like that. Okay, it's going to mess this one up, but it doesn't matter. Okay, finish. And then we are going to indicate the depth. So let's give or take. So if I go 0.983 and divide that by 2, enter, and then select. And there is okay, so now we have that, and which means I'm just going to simply use the callout. It's a lot easier and a lot quicker rather than having to type all the information. So I'm just going to use this. There's my Counterbore. Over here, there's the Counterbore. It looks good. All of the information that I need is all there, as opposed to adding all the dimensions and stuff. We have a few more little things to add, but that in itself can be done afterwards. Actually, it looks good. So, last but not least, we make sure that we go into our file properties. We change our title to tool holder. So, tool holder, project. So, TH120589, whatever the number you want. We'll leave that as is. And we are going to simply do an update. Close. There's our tool holder. We save it. We're done. So we've gone full circle. We've gone from the modeling of the part, which is right here, to the creation of the engineering drawing, which is right there. Hope you enjoyed it, and thank you for listening.